everyone. Hello to the video presentation of today. We're going to work on a problem from the 2010 AP test. You notice it's the first time we're doing a graphing calculator problem. We have a graphing calculator on there. I'm going to bring up my SmartInk tools, as a matter of fact, at the same time. And here's the problem at hand. Peter, could you, first of all, before we even start reading the problem, Peter, what do you notice on the question? What do you think it's going to be asking us about?
Something about regions.
Probably something involving either area or volume or something like that.
Yes.
And remember, we have our handy dandy calculator to work on the problem. I'm going to bring up my CAS calculator and change my screen so we can see the handheld while we're working. I'm going to throw that over there to you, Peter and Connor. There it is for you right there. So I'll read the information on here. In the figure above, R is the shaded region in the first quadrant, bounded by the graph of y equals 4 ln of 3x. The horizontal line y equals 6. And the vertical line x equals 2. They like to throw these words horizontal line, vertical line there to distract you from what you're looking at. If I'm looking at this shape right now, I see an upper bound at y equals 6. I see a lower bound of y equals 4 ln 3 minus x. Now I already know this is a calculator problem. So what do you think the first thing, Connor, I want to do with all this information is?
Put it in the calculator.
Put it in the calculator. You got it. So I've got my two curves. I'm going to go to my, turn off my SmartInk. Just in this application. Oh, I guess I just permanently disabled it. But hey, what are you going to do? So I'm going to go to my calculator page. I'm going to graph the line y equals 6. Hit enter. And I'm going to graph the line 4 ln 3 minus x. Okay, there they are. They look about the same. Obviously, the view is a little bit different. Of course, now I want the SmartInk on that because I was going to mark it. But what are you going to do? We're okay with that right there. And the first thing it says is to find the area of R. Guys, what's the equation for finding area?
Sup-low.
Sup-low. It's the integral of upper minus lower. Area is always integral. So we're going to be finding the area by getting regions just like so. And I'm going to write down what that would be on this page. The area would be the integral from where, I never looked to see where I was starting and where I was stopping. Did they give me that information on here? Well, which way am I slicing? I'm slicing along the x-axis. So I'm starting there and I'm ending there. So I'm going from 0 to 2 of upper, which was 6 minus lower, which is 4 ln 3 minus x dx. The x always goes on the end.
Mr. Brigham, you forgot a parenthesis.
I technically forgot a parenthesis, so that's a free creamer for Connor. Put that on in there.
Maybe.
The reason for the dx is the following. We're finding areas of each of these individual rectangles. So the height is upper minus lower, and the width is dx. So that's where that comes from in the problem. So I need someone to figure out in the calculator what the answer to this question is. Peter, where do you think I'm going to go to do that on the calculator?
Menu.
Calculator.
What am I trying to find, Peter?
Area.
Okay, so I'm going to go to blippity bloop, clickety clack,
Menu.
menu.
I'm feeling calculus.
I would feel calculus.
Can you feel it, Mr. Brad?
It's an integral.
It is an integral. And we're set up from 0 to 2. Now, I don't want to retype in what I already have in there because it's already stored in there.
Var F1.
I'm going to go var f1 of x minus var f2 of x. And let's say I got them backwards. I'm really not worried about it because I'll just change the area to positive dx. Hit enter. And gave me a number. It didn't give me it back as a nice number. I'll hit control enter. I've got my area equaling
6.81665 or 6.817.
Right, so what I do is I usually write it down all the way out. I know I'm going to round to the thousandths place. Did I write that down right? Yeah, I did. I'm going to round to that place. So that equals 6.817. 7. That's the correct answer for there. You actually, Peter, whether you knew it or not, can do area from here. Watch this, menu, analyze graph. Which one?
7.
Integral
Or
or bounded area.
you could do either of the two. Let's try bounded area. So I have to, the lower bound, to tell where to start. I started at 0. I type in 0 and hit enter. Where was it? Upper bound 2. Hit enter. And there
That's
is
so fancy.
there is the area.
Sorcery.
Sorcery. It is sorcery. And it works. The difference between integral and area is your area is going to always give back a positive number. Integral will cancel out things that need to be canceled out. Okay, that's the first part of the problem. Now we're going to keep going. Hopefully we don't mess up bad enough that we have to restart. But Elizabeth, if we do make a mistake, who do we blame?
Peter?
Absolutely. We just blame Peter.
Yep.
And then we'll re-record from there. Okay, the next part of the problem. Move the calculator over. Give me your calculator. There you go. Ooh, come on. All right. What do we find in next?
The volume of a solid when R is revolved around the horizontal line y equals 8.
So we're doing a volume of revolution, a volume of rotation. So what's our equation going to be?
Is it yaya?
It is ya. It's pi the integral. Ya squared minus ya squared dx. Now this is a calculator problem. I know that this part has to be the upper and this part has to be the lower. But because it's a calculator problem, I don't have to worry about it. I can just do the absolute value here. And even if I got them backwards, I'd still end up getting, it's not going to matter. I'm still going to get the right answer. So let's go back and look at the picture. And let's think about rotating. Where is the line y equals 8? It is way up here. That's our axis. When we rotate it, if we rotate this curve and this curve around, when we bring them up to the top, who's going to be on top?
I don't know which one is that. The bottom one.
Yep, the 4 ln. I get it wrong, it doesn't matter. It's okay, we're still going to end up getting it right. So we're going to come back to here, and we're going to fill our numbers in. Pi integral f2 minus a squared minus f1 minus a squared dx. What's my a, though?
Was it 8?
It was 8. Now, you see I'm using these terms f1 and f2. I really don't want to have to be writing things over and over and over again. So usually at the beginning of the problem, I'll write down that f2 is equal to 4 ln of
3 minus x.
3 minus x. And f1 is equal to 6. This way I never have to refer back to what's going on there. I'm not used to the music coming back, but I'm going to keep going. I'm going to push through. I think we can get through this.
Power
Keep her
through.
going.
I'm going to power through. So, I'm going to enter that into the calculator. I'm going to go to my menu. I'm going to go to my menu. I'm going to go over to here.
You going away, Peter?
Peter's
Yeah.
checking. Look, Peter's checking to see if he can come back. It's okay, Peter. Good. Pi. Let's break this up. Times the integral. Menu, calculus, integral. From same limits, 0 to 2.
C.
Of f2.
Minus 8.
Yep, I'm missing the parentheses, so I'm going to put that back.
F2 of x minus 8.
Minus 8 squared minus parentheses f1 x minus 8 squared. The music's loud, isn't it?
Yeah.
Yeah.
X.
Rip earphone users.
And enter. That'd be a crazy answer.
That's
168.
0.18.
And I'll wait for the music to die down, but it didn't matter. Come on in, Henry, we're recording a video. It didn't matter what order I put anything in there, because I could always just do absolute value signs in there.
Half the class is going to be in this video.
I know, could be. Could be everyone in the video by the time it's going.
Recording video?
Yep.
Please excuse the interruption. Nico Sedio, Jerry Card, and Alexandra Brush to the academic suite. Thank you.
Some weird.
I literally
Whoa.
recognize none of those names.
Remember we're
Sorry.
recording. Okay, so
Jerry?
that's the right answer for
Oh,
there.
Jerry.
Jerry Card. It's a good man. Okay, so we're on to the third part of the problem. Hopefully this music stops sometime soon.
Are we recording right now?
Yes.
Oh,
It's live, Henry.
But we can't pause it. Oh.
Can't stop, won't stop.
Okay, whoa, scrolling around. So the next part of the question says 4, 3, 2, 1. The region R is the base of a solid. We got our cross-sectional solids. And that's what we're gonna have. And what shape do we have? Each cross-section is a square. We like squared. Squares. S is always equal to upper minus lower. So on that graph, who's upper minus lower?
That one is looking at
F1
Yeah.
minus F2. But in the end, it doesn't matter. Because everything is squared, so upper minus lower doesn't matter. So I'm going to integrate that region. I'm going to integrate that region. So I'm going to integrate S squared from 0 to 2. And that will give me my cross-sectional solid. So I'm going to come down to here, and move my calculator over. And then I'm going to go to the integral, menu, calculus, integral, from 0 to 2. S squared is upper. X, outside the parentheses, minus lower x. Is that where the squared goes?
I believe so.
Yep, that looks right. dx. Oh,
Nope.
whoa! We got it, we're good.
All right.
Hit enter, crazy answer. Control enter. And I've got 26.666. It's a little scary. We got to round it to 26.267.
There we go.
Round it to the correct place. Just to prove,
Oh,
just to prove to you that if the order wouldn't matter, if I had changed these to F1,
Oh my god.
I'm gonna do it.
You can do that?
Yep, you can just
That's
change that number on there.
crazy. That's
2,
nuts.
Where is it recording?
hit enter. Yep,
Yeah.
I got the same answer we got there. Hey, what if this was a half of a circle? How would the answer be different from this?
1/2. No, that's a square, not a circle.
Nope, think about Tyler. Just think about Tyler.
It'd be 1
Over 8.
Not 1, because it's a half of a...
1/6.
If there was a half a pi in here,
1/6.
Tyler did the half pi first. So the pi
Oh, yeah, it's pi over.
got 8. And that would be the answer for that one. Okay, we've recorded one problem. I'm going to make another one in a second and send you that video. Say goodbye, everybody.
Bye.
Hello.
That's the opposite of goodbye.